So for the contestants, they will present, and then afterwards they'll go set up their boards after they're done presenting. So you guys worked really hard. So we're really proud of you. We're gonna have 4 special guests. So non-homeroom teachers, Mr. Inu, round of applause. Okay, and then we got Mr. Son, round of applause. Okay, and we got the newlywed Mr. Sean and JJ 선생님, round of applause. Woo! So they'll be unbiased as possible in terms of the judging, right? So please don't just look at them. Make sure you guys are also looking at the main audience here, all right? Okay. So yeah, we're gonna do 7th grade, 8th grade, 8th grade first. We'll take a break, 10-minute break, and then after that we'll do 9th grade, 10th, and then take a break for 10 minutes, and then finally we'll do 11, 11, 12. As you guys can see the list here, all right. And we're gonna go to the boardwalk, and you guys will come back, and we're gonna gather all the points, and we're gonna announce the winners at the end. And Mr. Yun will come and pass out the winning team prizes. Okay. So I heard the prize is gonna be real money, okay? Oh, all right. So yes. Okay. So why don't I pray for us? Okay, we'll pray and then we'll begin. Okay. Shh. Okay. Let me pray. Heavenly Father, I thank you once again for this time and opportunity. Thank you, Lord, for giving the students a lesson again this semester in hard work and teamwork. Lord, we cannot do great work alone by ourselves. We need one another. We need community. And Father, when we come together and when we're able to be flexible, when we're able to communicate well, and when we're able to serve one another well, then Father, we can do great things in your name. So I pray that through this science fair, that you may continue to teach us what unity and fellowship truly means and how we can work together to bring your kingdom here to this earth. In Jesus' name we pray. Amen. All right. So round of applause for Grace class.
아. 우와, 신기하다. 서로 넘긴 거지. 시작하는 거야? Hello, we are Yuna, Arin, Yedam, Unsor, Connie, and Uje. Before we start the presentation, I have 2 things that I would like to tell you. First of all, we have one absent student. Her name is Arin, and she is not able to join today because she has gone traveling to Japan. Second is, this is our first science fair projects in middle and high school, so which made us really nervous, and we are cute little seventh graders. so, so please let it slide, even though we make some mistakes. Okay, then let's get started. This is our role allocation. Our content. Okay.
Our topic is which toothpaste can protect our teeth the best. At first, our topic was not the same as now. What kind of liquid is most dangerous to chicken bone? We found it on the internet. However, Mr. Solomon recommended developing our topic, so we accepted his advice.
Now we will talk about some materials for the experiment and how to do it. We have 6 chicken bones, Coke, we use Coca-Cola, 6 plastic cups, and 5 types of toothpaste. We have polarized toothpaste, bamboo salt toothpaste, Mavis, the expensive one, 2080, the cheap one, and whitening toothpaste.
To start this experiment, first you have to prepare the materials, which we mentioned just before, bowl and toothpaste. Second, apply toothpaste to the chicken bones. Third, pour Coke into 6 cups and put each food separately in each cup. Fourth, reapply toothpaste on a certain day for 3 weeks. Reapply it every Wednesday. Lastly, make observation and compare the chicken bones.
We expected Marvis to be the best toothpaste because it is expensive, so there must be a lot good ingredient to compare to the other toothpaste. And worse should be whitening toothpaste because we thought each ingredient must be mainly focused on whitening effect, not for protecting teeth. However, the result was shocking.
Which toothpaste do you think would be the best? Our predictions about the worst toothpaste was right, but the best toothpaste was bamboo salt toothpaste. You can see in the picture, it hasn't become black like the other ones. Actually, we didn't have big expectations on bamboo salt toothpaste. We couldn't believe the result. As you know, salting is a method for conserving food. Salt helps to preserve food like kimchi or fish. Food doesn't easily go bad when you salt it down. You assume this effect worked on the bone. From the result of the experiment, we can see just because it's expensive, it doesn't mean it's the best. Next time, if I have to choose toothpaste, I'll go for salt-based toothpaste.
Before you wrap up the presentation, we'll have a short quiz time. The question will not be that bad and hard, and if you get the answer, we'll give you some cookies, so please pay attention to it. First question is, what kind of toothpaste did we use in the experiments? 은성 선배. Yes. One more.
Okay.
Okay, second question is how long did we do this experiment?
Okay.
Next is what kind of toothpaste was the worst? 정빈 선배. Yes. Last is what is the best toothpaste in the experiment?
다른 번.
한 분. Almost close. 은솔 선배님. Close. Vamos. 맞았어.
Next is our impression after the project. Honestly, I didn't expect our team would be here today. I'm really thankful to teammates who worked hard. And like I said at the beginning of the presentation, we were very nervous, but I'm glad this finally ended. Next is Arin's impression. Our teamwork was pretty good and we communicated well. It was not that difficult to fix a day to meet together, and everything went smoothly.
During this science fair, I learned how bad soda, such as Coke, is for our teeth and which toothpaste works best or not. Also, with this opportunity, I had fun experiment with my friends on team and conducted a science fair. I was more proud as I finished it because it was my first time to doing it.
When I first heard the opinion of conducting an experiment about a subject of toothpastes, I felt this experiment wouldn't be successful. Yet it was fun, and I realized it had a big impact on our dental health. Also, it felt good to experiment with good team members. I hope to this experiment with next time.
It was my first science fair, so I didn't know what to do. But our teammates did very well, and I learned what to do. Next time, I sure I can do better than this time.
During the project, I learned something that I didn't know before, and I felt fun too. Of course, it was a little tiring to do the project, but my teams did very well, and I think we did the project more easily because our teammates made a good teamwork.
This is our picture. Worked hard.
걸어줄게. 잠깐. 시작해. 오케이. Okay. Hello, we are Hwani, Seungwon, Jaewon, Jiho, and Seon. And we will present up the sinkhole, and our team name is the following. We were curious about the sinkhole and want to know about the sinkhole, so we choose the topic of the sinkhole. So, and some of you are curious about why our team name is falling. We choose this name because when the sinkhole happens, the sudden falling extent is happens, so we choose this name. So now our presentation about sinkhole is start.
First, what do you think a sinkhole is? You just know that there is a hole in the ground. The sinkhole is common when the rock below the surface is limestone, carbonate rocks, or rock that can be dissolved in naturally by groundwater. As the rock melts, it creates space and caves underground. Sinkholes are dramatic because the ground usually left untouched for a while until the basement gets too big. If the ground above the space is not sufficiently supported, the surface can be suddenly collapse. This collapse can be small or large and can occur in house or where there is a load above. This is called sinkhole.
Next is our hypothesis. We examined the sinkhole and thought it would normally happen because of limestone and pipe when we did the experiment. We thought that tissue would melt using tissue instead of limestone. So we went spaceborne because the tissue is melted like limestone. Also, instead of a pipe, we used a hose to make a hole in the middle, like a broken pipe blowing water, and we thought it would drain and make a hole.
We did two experiments with sinkhole. The first experiment is because of sinkhole limestone melted. The experimental method we did is as follows. First, pour the soil into the plastic box and fill the tissue. Second, spray water on it. Third, then the soil is turned off by a empty space created by a tissue being wet and melted. Unfortunately, this experiment was failed. But why do we fail and how can we do next time? We think the reason we failed the experiment is because of the amount of the tissue and soil should be adjusted appropriately to make holes.
And then we want to try a failed experiment. So when we do the experiment again, we be careful to put too much soil and little tissue. So there isn't enough space for dissolved tissue. Also, the tissue absorbed water. There was not much difference in volume after spraying water and not spraying it. So we should have sprinkled a small amount of water evenly, but we sprayed a lot. So in this experiment, we succeed. We want to reproduce limestone melted because of acid rain, and we reproduce with tissue.
The second experiment is sinkhole caused by pipe. First, we make a hole in the bottom of the plastic box and both left and right side of the box. Then we make a hose across the box using the hose. Then we make a small hole in the hose. Second, we pour soils and tissues in the bottom of the box. Third, we make a water flow in the hose. First, water will come out from the
hose and then flow away soil, so the sinkhole will happen. We want to reproduce that broken pipe or cracked pipe was come out, water is come out from the broken pipe, so the soils are flow away or the limestones are melt. So the sinkhole was happen. And through this process, we are succeeded in this experiment.
And our result is this. In the first experiment, the sinkhole is formed because the acid rain dissolved limestone. The tissue is melted, so the sinkhole is formed. Second, broken pipe make limestone melt or the soil flow away in other ways. For this, the hose with a hole make a sinkhole because the water make limestone melt or soil flow in other way. So the sinkhole is formed.
There are many types of sinkholes that occur on Earth. Except for the sinkhole we tested, what types of sinkholes are there? So let's find out. We found 3 types of sinkhole. First is that excessive groundwater pumping is a problem. When the number of groundwater decreases, there are large empty spaces underground, and over there are high and heavy building above the empty space. Then, because of big pressure, sinkholes happen.
Secondly, gas mining is the cause. When mining natural resources, shale, they dig into the underground shale and then extract the resources there. Normally, they put other material in the empty space, but sometimes they put a small number of things that need to, or don't fill it as a result. The space of the resources originally occupied disappears, and the above of load cannot be endured, resulting in a sinkhole.
Third, subway construction in cities as the cause. For example, subway line 9 in Korea was built in a way that tunnel continuously drilled underground, rather than a way to dig a hole to cover the structure, and because the above ground was like a fragile sandy field. A sinkhole was created because sand goes into empty space or go to other space. In particular, about 60% of our sinkhole in our country distribute along the subway map of Seoul.
Also, while we doing this experiment, we have the question arose. First, how we can know the sinkhole will happen, and how big is the sinkhole? So we are research about these questions. First, how we can know the sinkhole will happen? First, the sudden tilt of the surrounding area, or some part of the road was bumpy or break for no reason, and the road was wet through the aging water pipes, or hard to opening and closing the windows and doors. An accident frequently happen in aging water pipes. So this is the we can know the sinkhole will happen, and but the big sinkhole are not easy to predict because of that happening very suddenly. Second, how big is the sinkhole? The average size of the sinkhole is 1 to 50 meters, but the very big sinkhole is about 600 meters. But the Seoul Lotte Tower's height is about 555 meters, so you can maybe predict how big sinkhole it is.
Lastly, how do we prevent it? To prevent sinkhole because of broken pipes, even if they cost much. The old pipes should be replaced regularly to check for durability. Also, to prevent sinkhole from because of groundwater, we shouldn't force groundwater out. Investigate in advance whether there is a risk of sinkhole when making road. There may be a lot of groundwater burned in the ground, and there may be a lot of limestones. Or there may be a cave, so road should be built in the consideration of that.
So it is our end of the presentation. So for Yohani,
승원,
서현?
지효.
재원.
thank you.
우가. 차차. 1, 2, 3. Hello everyone. We are Metronome Team. Our topic is survival with seawater. Our team members are Lee-won Kim and
인성강 and
예현 리맨. 예나 킴.
We are gonna do a role play as a presentation. Please listen carefully until the end. 음향 안 나오나요? When Robinson and Crusoe open their eyes, they are on an island. They couldn't remember why they were there. First, they decided to gather some food, so they ran around.
Where are we? You know? Oh, I don't know, but I'm sure that it is an island. I think you're right. Aren't you hungry? I think we get some food. Yeah, you're right. Oh, let's start finding with the right side. Right side there.
Soon they were getting thirsty. However, there was no fresh water on the island. Finally, they were in danger of swooning from dehydration.
Oh, why is there nothing to eat? I'm so thirsty. Can I drink some water?
For Robinson, there is only seawater
we don't drink it. I saw the article that the drinking salt water is dangerous because it can cause the dehydration.
Really? Oh my gosh! I'm gonna lose my mind.
Oh, Robinson!
Suddenly, two primitive people called Dubi and Duba appear. Hey Dubi, who are they over there?
I don't know. Are you curious?
Yes, let's go over there. Since they discovered the drifters, they wake up the drifters. And they decided to teach how to turn seawater into fresh water.
What? Someone's lying down.
What should we do?
I don't know. Can you hear me?
Oh, give me some water.
Oh, I'm so thirsty. Okay, do you have some fresh water? Let's teach them how to make fresh water from seawater. They explained there are two simple ways to do experiments.
All right, guys. Okay. There are many ways to desalinate. Okay. Desalination is to turn seawater into fresh water. It has been used, but it isn't popular yet. They include reverse osmosis and experiment.
Reverse osmosis move water from high to low concentration. This principle is more efficient than evaporation, but it is so complicated. Then we can try evaporation.
Well, we'll use an arc lamp. Arc lamp that replaces a bonfire. UV lamp, then place the sun. Okay, let's find out which. Okay, it's more effective.
I think it would be better to desalinate with an arc lamp.
Oh, I think too. I assume that the heat of alcohol lamp affects directly.
Alright, guys, we'll go on desalination with an arc lamp first. For the materials, we need some salt, alcohol lamp, a beaker, and a little beaker, and some water and a salinity meter. We are ready to in survivor box.
Sound great. As procedures, okay, fold and cut the wheat film and make it like a cone. Ooga ooga.
And make salt water and taste it. I mean, we just put salt water in a small beaker.
Okay. Put a small beaker inside a large beaker. You need water.
And put cold water in a corn and put it in a big cup and turn on the fire on the alcohol lamp.
Got it! And then?
Okay, next, the last step. Steam rice and cold water creates purified water in a small beaker. Cha-cha.
Look at that, water started to boil in the beaker.
And that because of the heat of the fire in the alcohol lamp.
At the same time, the cold water inside the OHP lamp meets the hot water, bubbles from the boiling water and it drops on the surface.
Okay. Finally, the drumlets on the films film and surface pour into small beaker. Uga uga.
And we got some fresh water. Let's drink it.
Oh my gosh, there's no so salty tasty. Let me drink.
You're right. It is surely fresh water. Wait. I will tell you the
Result of our experiment. First, we got 7 milliliter of water from 160 milliliter of water, and salinity became 0% from 1.9%.
There are other ways make fresh water. Second way is solar method of fresh water.
Um, for the materials, water and salt and UV lamp and bowl and wrap and salinity meter. And the way is simple. First, put salt water in a bowl, and second, place a cover small container in the center, and third, cover the bowl with a transparent wrap.
Wait. Why are you wrap it around with the plastic wrap?
That's because we have to prevent the steam from flying away. Uga uga.
Oh, I see.
And then place a stone on the transparent wrap and finally place the bowl under the direct sunlight.
Hooray! When the UV lamp shoots ultraviolet rays into the Raji bowl, the water started to heat up. Then the water in the big bowl began to evaporate. The evaporated waters began to form doubly on the surface of the wrap.
Some drops of water formed on the surface, and the water flowed into the empty bowl through the plastic wrap. In this empty bowl, desalinated water was put in it.
Then we can drink more water.
Wait.
Hey.
I will tell you the result of this experiment. For this, we got 20 milliliter of water from maybe 600 milliliter of water, and salinity become 0% from 1.9%.
Crusoe! I think the scientific experiments bring back memory.
Oh, me too! The watching scientific experiments made me remember we are scientists.
두비두바. We were traveling, but the plane crashed landing.
Huh?
No way!
Oh, thank you, Dubi. We can learn about desalinated water. So, what do you think the advantage and disadvantage of this experiment?
Okay. The alkaline is the advantage is that you can get a lot of water over a short period of time, and it is efficient in shorting time. But solar heat, okay, The advantage is that water can be effectively obtained with pure materials is encased on this tree.
And what do you think, Duba? Duba.
Do we steal my script?
Hey, hey. It's
Let's
okay, it's
skip.
okay. Let's get it. What do you think, Duba?
We think alcohol lamp was better.
Yay!
Yay! That's because alcohol lamp take less time than solar heat experiments, and it is less affected by the weather.
Next, we will talk about more teach for you guys. What is desalinate? Because we will forgot to explain for what is desalinate. Ha ha ha.
And this is the models of desalinate water. And the refrigeration is the different way to desalinate water. It is when seawater becomes ice, the salts in seawater fall out only pure water becomes ice.
This day, the purpose of the desalinate is to obtain drinking water in the industrial water.
And desalination is widely used on the island.
Currently, there are more than 100 desalinate facilities in Korea.
And we need to save the water.
Thank you for listening our presentation. Thank you for our listening to presentation.
And we will talk.
시간. Thank you.
All right. Everyone clap for middle school. Fabulous. All right. So, we are running about 20 minutes or so behind schedule. So, we're supposed to have a 10-minute break, but we want to let you go at the right time. So, very quickly, please, if you have to go to the bathroom, go run. We're have about 5-minute break, okay? All right, get up, stretch your legs, go do that, and then we're gonna have 9th and 10th present next. So be here in about 5 minutes. Got it?
Okay, sit down, please. Let's go.
Thank you.
All right, so we're gonna move on to high school. Okay, we're done with middle school. We're gonna move up to high school, starting from 9th grade. All right. Just a friendly reminder that 10 minutes is max, and tech team from the back will give you the reminder with the board, okay? So we'll give you a reminder so you can do your best. All right, so round of applause for high school.
Let's begin.
Okay, these are the life summaries of abandoned plant survival. Good afternoon, Haven students and teachers. Our project name is I Survive Plants, and we are the team of Yuan Zhang.
And Sangyeon Jang.
So, our project is about plants. To be specific, tracking the death of the plants, which relates to the lesson we learned this semester, and not only that, global climate change. In the world where global environmental change rages, how will the plants survive by fitting into those circumstances? Let's figure it out right now.
So, before we chose the topic of the project, our team thought up the contents of the photosynthesis and how the plant lives in certain circumstances. After a few thinkings and gatherings, our team thought that how the plant would survive in the extreme conditions such as flood, drought, or bad densities of air. And also, according to from the background research, our team has found that the plants die differently when they do not provide water, air, or the external circulation of the air. Because of this interest, our team started to figure out this topic, and the steps will be revealed in the next sections.
Okay, so our project is mainly about what happens if we only provide two essential factors for the photosynthesis to verify what is the most important factor for the photosynthesis. For example, if we're not providing water, we're still providing light and the external air circulation. As we started the project, we had two questions. First is what happened to the deprived, which deprived plants would die first, and the next is what idiosyncrasies would the plants show before they die. So how the plants die and how the plants change differ from one another. So we decided to observe this by taking pictures for a long period. First of all, we thought that the plant that we didn't provide air would die first, as we determined air as the most important factor for life. Following, we thought that the plant that we did not provide water would die with a weak condition. Lastly, we also thought that the plant without light, that we didn't provide light, would die following with them, which is vulnerable but less vulnerable than the plant that we did not provide water. We did not set the exact hypothesis for that because we had no idea what would happen to the plants.
For the material of the science experiment, we have prepared the fascias. That's our plant. And for the supplemental materials, our team has provided the artificial benchmark beaker, cut delivery box, and the zipper bag. So move on to the procedure. Our team has provided the 4 fascia japonica and has set the environments for that. For 3 of those plants, we omitted the one factor for the photosynthesis. One plant, we didn't provide any water. Another one, we didn't provide the sunlight by covering the whole plant by the cut delivery box. The other one, we blocked the whole external circulation of the air by putting the whole plant into the zipper bag. How about the one plant left? We used that as a control variable for this experiment. So let's begin our experiment. After we begin our experiment, we provided 60 milliliters of the water once in every 5 days, except for the plant without water. We also took the pictures of the plants once every 2 days and recorded the number of length of the stems, and the colors of the stems and color of the leaves once in every 2 days until the plant dies.
So this is how we water the plants. So, okay. So the control fascia, the fascia that we provided all factors, has grown really well, healthily. As you see in these photos, the color has turned green and darker to darker green. And the plant that we did not provide air, there was inflation of the air in the zipper bag, and we figured out that it was because of the interaction of inhaling and exhaling of the carbon dioxide. The plant did not grow much, as you see in these photos. This is how it eventually turned. And then this is the plant that we did not provide water. It actually started normally, but as it grew, the color turned green. The color green turned lighter and lighter. Finally, the color turned into yellow. And during the experiment, actually the stem of the plant has bent, and it led the plant's death. Lastly, the plant that we did not provide sunlight didn't grow well too. As it grew, the color turned green to yellow, same as the plant that we did not provide water, as you see in these pictures. And this is the result of the plant.
Now, let's figure out the results. First of all, like she stated, the plant, which is a control variable, grew terrifically. It was the only plant which showed a positive number for the growth. And for the plant which blocked the water, this PPT has some problem. Maybe there was some technical problem with it. This is the plant without air, no, plant without water, plant without sunlight, plant without external circulation of the air. Let's move on. The color of the stem for the plant without the air, it didn't die, not like we expected. However, the color of the stem changed into the brown. Here you see the green and brown chart, and you'll see the one plant which is under down, which means the stem has turned into the brown. Moving on, we're going to introduce the result of the plant without sunlight provided. It didn't die as well. We were astonished by this. To add more, only the color of the leaves and the color of the stems changed, and the color of the leaves have changed into the yellow, which sustains this in this graph here. Lastly, the plant without water provided eventually died. It started to be dry from the edge of the plant, and the dryness spread to the middle. One day, the stem just eventually bent. Like you see from this graph, there is only one factor which touches the bottom of this graph, which means the plant has passed away.
To sum up, water was the most important factor for survival of the plant, but that doesn't mean the water is always most important factor. All factors are essential for the plant survival.
Moving on, we have figured out the one important thing we learned from this experiment. Before we block the external air circulation, we haven't thought of the cellular respiration of this plant, so we thought because the external air doesn't come newly into the zipper bag, we thought the plants would die, depriving of the ratio of the air. However, it is continuing doing a process of the photosynthesis and cellular respiration, so the plant sustained its condition pretty well. That is one of the most important things we'll take from this science fair.
Lastly, we wanted to warn about putting plants into drastic conditions. Think about drought or smog. These could be the reality for the plants while humans did not intend.
We hope that audiences all here took things from our science fair, and thank you for listening to our science fair.
Hello, everyone. My name is Kane Cho,
현서 John,
Yojo Kim, and Esther Kang.
and we are Team
The Rock.
And now we would like to present to you our project that includes plants and microgravity. So, our group has been wondering what will be the best topic for our science project. And we eventually got to the question, is it possible to grow plants out in outer space? So we created our own microgravity environment. And that led to the question, in which type of gravity will plants grow the best? Our hypothesis is that plants in regular gravity will grow the best because the plants are adjusted to grow in the regular Earth's gravity. So this experiment is consisted of comparing 3 different kinds of plants, one grown in regular Earth's gravity, another one in a gravity changed after growing its roots, and finally one in the microgravity environment we explained earlier. The materials needed for this experiment is an Arduino kit, which will be the main thing we'll be making out of the clinostat, which is a machine that creates the microgravity environment. Musun seeds, which is a type of grass cress, that's where the title comes from. Tweezers, Petri dishes, measuring cups, duct tape, agar powder, soil, and flower pots, and a cardboard box.
To understand this process well, you have to know the information. Firstly, normally plants grow and rely on gravitropism, and it is also called a geotropism. Our main topic is about each amount of gravitropism affect to musun. Second, gravitropism allows plants to know which is up and down, so it can make roots grow down and shoots grow up. Second, gravitropism relies on plants' perception. It means the environmental sensing of stimuli. Third, perception of gravity occurs in special cells called as statocytes. And fourth, the cells contain small particles called as statoliths. It is synced to the button of the cell. In response to gravity. And then the signal transduction came out. Signal transduction is how cells communicate with each other. And then the final step is a response of the growing cell to the signal indicating which way is down.
Okay.
In a microgravity environment, there's no gravity to pull statoliths to one side of statocytes. So the plants don't know which way is up and down. And then the scientists can simulate this microgravity environment on Earth by using device clinostat. And then plants may still rely on other processes such as phototropism to determine its growth.
Okay, so as Hyunso explained it before, to make the perfect condition of microgravity, we need to make a clinostat. But the whole entire clinostat machine costs a lot of money, which we couldn't really figure it out in our budget. So we made it by ourselves by using an Arduino kit. So an Arduino is an open source electronics platform based on easy to use hardware and software, which we could also call it as a small and simple computer. The main boards are equipped with sets of digital and analog input-output pins that interact with other circuits. So we simply downloaded the Arduino application where we insert the codes, which are also called as the Arduino language. But to make the clinostat, we bought another motor that spins while it is connected to the Arduino. So now we connected these G and D pins into the breadboard to ask for the device to work. And we also inserted the Arduino language, which is this. So now we connected the potentiometer, which helps to control the speed of the motor while it is attached to the Arduino. And now we sent all of the codes to the Arduino application. Our clinostat is ready for the experiment. So to jump right into the experiment, we need a few steps to go over. First, we made the Arduino clinostat, and then we need to make a special solution that carries our mucin seed while it is in the Petri dish. So by using 1.5 gram of agar powder and 100 milliliter of water, mixing and boiling them together will make the special solution that hardens into a solid. So now we carefully embed the seeds into the Petri dish, and we place 9 each seeds in each dishes with a certain space. But before moving on to the next step, we need to check if the seeds are surely attached to the agar solution by flipping over the dish slowly. For the constant gravity and clinostat and the rotated 90-degree on top of each Petri dish's lids, we wrote whether what gravity was affecting them. And for the constant gravity and rotated 90-degree dishes, we attached it onto a box where it was pointing into the same direction. And for the clinostat, we set it by the window where it was plenty of sunlight. And now all we have to do is just wait until our muesins to grow.
Now we will be going into our experiment log, or also we call it the Musun Journal. On the first day, we tried making our clinostat out of the Arduino kit. However, we failed. So we tried to make a clinostat out of a fan. However, that also did not work out because the seeds could not withstand the high voltage spin of the fan. And because all hope was lost, we were about to give up. But thankfully, Hyunso's dad, who is an engineer, was able to help us create a clinostat, and we could continue on with our experiment. On the first day, the seeds in constant gravity and rotated 90 degrees started to germinate, but the ones in the clinostat were not able to yet.
Second day, the seeds started to germinate and they started to pour off the agar solution. For the clinostat, we guessed it was because of the spin. Also for the other 2 dishes, we predicted that the seeds were started to grow and made the agar powder solid to speed apart. The roots have barely grown yet.
At third day, roots grow about 1 centimeter long, and we rotated 90-degree for rotated 90-degree Petri dish.
On the 4th day, we ended our experiment because we thought that the roots grew enough to determine the results, and also the agar solution started to mold. But in the end, the mueson that grew in the constant gravity has grown about 7 centimeters, and the mueson in rotated 90-degree gravity has grown about 6.3 centimeters, and the mueson that grew in the clinostat has grown about 3 centimeters long.
To conclude our experiment, we will share our results. Our hypothesis was correct. The mueson in constant gravity was the longest, and the roots were long and straight. The mueson rotating 90 degrees was quite long too, but shorter than mueson in constant gravity. The mueson rotating 90 degrees was quite long too, but shorter than mueson in constant gravity. Also, contrary to the mueson that grow in constant gravity, the roots spread widely. Lastly, the clinostat mueson was the shortest. However, it had the most seed germinate out of the 3, and the roots were curved. From our experiment, we are able to also know that the plants can germinate in a state of microgravity, so we can predict other plants can grow in space. However, plants to grow superior in the Earth's gravity. We have been through many trials and errors, but we are content that we have successfully wrapped up this dreadful experiment. As a side experiment, after we ended our experiment successfully, we are curious if the mueson that grow in the clinostat can also grow in the flower pot again with soil and constant gravity. So we carefully picked the muesons from the agar solid and planted them in the soil. And we found out that the muesons were able to grow again in the soil too.
So wrapping up, we had a lot of fun during this experiment, and we will remember this experiment as a treasured memory. And we're also looking forward to eat our muesons as the toppings of our California rolls. So thank you for listening to our experiment log.
And
빨리 하라고. A long journey to the universe.
That's right.
Hello, we are the three tomatoes, Seungni, Seun, and Songa, and we did the experiment osmosis. We call three tomato because our face easily get red when you get too much attention. So focus if you want to see it. I have a question for you guys. Here is salt water, sugar water, rice water, lemon juice, and milk in front of you. Which of this do you think has the highest concentration? It's hard to determine by only looking at it. You also wouldn't be able to figure out by smelling, touching, or tasting it. So we want to introduce the method that might determine this.
It's called osmosis, also the title of our experiment. Osmosis is the movement of water molecules through a semi-permeable membrane, which is a membrane that lets only certain materials across. Let's look at this image. This beaker has a less concentrated solution on the left and a highly concentrated solution on the right, with a semi-permeable membrane dividing these two. However, these two solutions don't stay the same. They want to balance both sides. So the water molecule in the left, less concentrated solution, moves through the membrane and to the right, making the two solutions balanced. This is called osmosis. Using this concept, we constructed an experiment that might determine the concentration of our 5 materials compared to each other. We prepared 5 beakers, each with 200 grams of distilled water and 15 grams of each material in the semi-permeable tube, and we put each tube into each beaker. Because the material inside has the higher concentration than the water outside, the water molecule will move into the tube, making the tube grow heavier. At the end, the heaviest tube would mean the highest concentration.
So now here are the 5 different liquids that we put into the semi-permeable tube. We did a little background research about these 5 materials. First, salt water is a solution where salt and water is mixed. We actually use salt water as a comparison to other materials because it was too obvious that it will have the highest concentration. Second, sugar water is a solution where sugar and water is mixed. We mix 6 grams of salt and sugar, each to 60 grams of water. Third, lemon juice is 90% water and it is rich in vitamins and is highly acidic. Fourth, rice water is 99% water and it has some nutrients from rice when the rice was washed. And lastly, milk is more than 80% water and it has carbohydrates, fats, proteins, and calcium. And then we made the hypothesis that milk will cause the greatest osmosis out of the 4 materials, excluding salt water, because milk is opaque and it had the lowest percentage of water, according to our research.
And our experiment is begun as I described earlier. We put 15 grams of each material in the tube and put the tubes in the 200 grams of distilled water. Every 30 minutes, we pull out the tube and measure the change in rate. Here's the graph that record for our experiment, and you can see there have a relative contents change in a rate. For the final result, sugar water was 17.7 and salt water was 19.1 and milk was 16.9 and lemon juice was 16.3 and rice water was 13.7. Because of the high concentration, salt water absorbed the most and weighed the most as we expected. However, sugar water weighs 0.6 gram more than milk, indicating sugar water had higher level of concentration than milk. Through this experiment, we can figure out the concentration of 5 materials compared to each other.
Osmosis occurs in many living organisms, occurs in human bodies. One of the parts that most osmosis occurs in our body is blood. We are curious about the blood's concentration and how our materials in semi-permeable tube would react in such environments. So we blended the the second experiment the exact same procedure as the first one, but this time with blood instead of water. Artificial blood is not an easy material to purchase, so we found the artificial blood. The real artificial blood that can be used as the substitute of blood is not yet invented by the scientists, but they're still working on it. What we got was the artificial blood that can be used that is used for practices for nurses, but they can't use it for any medical purpose. But it still has a similar concentration with the real blood, enough for our experiment. The artificial blood consists of 3 main materials. With these materials mixed with water makes the artificial blood.
So the same procedure as the first experiment, we conducted our second experiment, this time with artificial blood. And and this is the graph of our experiment results. Looking at this graph, we found it really weird because at first 30 minutes, the materials seemed to decrease, but after that, the materials are all increased in its weight. This is really weird, and we had to search for our reason for this alteration of the results. And we found from the site that we had bought the artificial blood that the viscosity of the artificial blood gradually decreases after the lid has opened. Now, viscosity isn't always the same thing as concentration, but in our experiment, after looking at our results, we concluded that it had some relations. Let's look at this graph again. After 30 minutes, all the materials decrease in its weight because the viscosity of the artificial blood was higher than the material inside, so the water in the tube was lost to the environment. However, as the viscosity of the artificial blood gradually decreased, some of its water was gained again, and so the weight of the tubes increased again. And as for the sugar water, it had recorded the second in the first experiment, but it recorded the last in the second experiment. We think this is because the sugar water got the thickest part of the bottle of artificial blood. So the final result was lemon juice, salt water, and milk tied with 15.1 grams, and sugar water got the last with 13 grams. Out of these three tied materials, salt water had reached its highest peak.
And these are the abstract of our experiment videos. So. Can someone play this video? In conclusion, we experimented with osmosis occurring between different materials. So we could absorb and learn about this phenomenon. And we think it was a good try, and one day I hope you to find more about osmosis in our body. Thank you.
Cool. We're going to have a quick 5-minute break again. If you have to go to the bathroom, go to the bathroom, stand up, stretch your legs. After this, we're going to have 11, 11, 12.
Teacher, can you give it to Mike?
Be back at 2:45.
윤현아, 저 보드 좀 정리해 줄래?
have 3 left. So sad, right? Oh, almost all done. Okay. So this is our top of the top, our cream of the cream, cream of the crop, right? 11th, and 12th grade. Round of applause. All right. So before we get started, please stretch your bodies. All right. Make sure blood is flowing to your tired muscles. Okay. Make sure your head is still connected. All right. Guys, one quick reminder is that after 11, 11, 12 finishes, you guys will have 11, 11, 12. You guys will put up your boards as soon as possible and set it up. And then we'll give you guys time to judge. Pink stickers are for the middle school and the library. And the yellow stickers are for the high school on the second floor, okay? Choose wisely. Do not choose your own. 양심. Okay, all right? Choose other groups, okay? And one last thing is, once everything is finished, you guys will come back here and we're gonna get the winners, right? We're gonna announce the winners, okay? So please come back by 3, I think maybe 50, okay? And then we're gonna announce the winners. After everything is over, you do not throw away your science fair boards at school. Where do you throw it away? At home. If I or any teacher, we go home and then 길거리 있어. 있으면 돼, 안 돼? 안 돼요. If we find any pieces of your science fair boards out in the streets, okay, your science fair group grade drops down, okay? All right, just so keep that in mind. All right, round of applause. Okay.
Okay. Hello, we are
The
Son of Water. And we are Yejun and Jiel and Debbie. Okay, we'll start. So, what do you guys see in this picture? You may see a boy, and I think this boy bringing the water to his family. Around 842,000 deaths occur annually from the ingestion of dirty, unsanitary lake seawater. So, our question was this: how can we help those people living in impoverished areas without clean water?
So we decided to implement the ubiquitous solar energy into our model as we filter this nasty water into these clean water, bringing clean water back to those people living in the impoverished areas. And so this project was especially hard because there were no much information about this project, and we used no kit, and we used our research, and it took trials of errors and took a really long time to make our own solar filtration model. Woo! So this is an initial prototype of our model. So this is not the final one. And as you can see, this filter has 2 separate parts: the solar engine and the filter itself. And so first of all, the solar engine harnesses the solar energy and generates into heat energy as it changes with this glow plug. And then using the filter, this is a filter, and the nasty dirty water is down here. And if we put this in the light under the sun, after a while, this distills into clean water on top with using condensation and evaporation. And so our model uses the primary methods of boiling and evaporation to filter out the dirty water, because the main problem was the pathogens that killed most of the impoverished areas of people who drank those water. Our main goal was to get rid of the pathogens, and also our goal was for this engine to reach at least a temperature of 65 degrees so that most of the pathogens would die. Next is our hypothesis.
Oh, we had 2 hypotheses. At first, we thought we would be able to create edible water by creating the solar panel heater that will help purify the water and build water purifier throughout the waste.
After building up our solar panel, we specified our hypothesis. We hypothesized sticking the CDs together in between a conductive pad and encircling with a solar can will create a solar cell that will harness more energy than before.
So next is our procedure. We disarrange the photo frame and position the 15 CDs on top of it, and mark on area to drill 2 holes to the frame and 1 in a CD, and wrap the front with foil. And next, make 5 conducive tracks using foil and glue it to the 5 CD lanes, and overlap the hose from the CD and the frame, and let cable draw the hose. And screw the negative cable to hold placed hole, and tape the CD lanes, and screw the positive cable to the overlapping the bottom of the CD, and connect the 2 cable wires with the glow plugs, the positive going below and negative up top. Next is our filter. This is our filter, and we drill 2 holes to the 2 leads of a long container and connect those 2 leads, overlapping the 2 holes in it, and slid a PVC pipe through the hole and glue the leads to the half.
This is the procedure of making our final solar engine. First, cut out soda cans into rectangular shapes and spray them black. Second, pile another layer of CD on the panel and glue the conductive tracks on top. Third, repeat this process until there are 4 layers. Fourth, glue another foil track encircling the CD sticks. Fifth, encircle the CD cells, each with the soda cans on the sides. And last, stick the solar cans into the edges of the panel.
So these are the these are the 4 main materials we use: CDs, foil, PVC pipe, cable lines, which are important for our model. So the CDs contain silicon, which is a great semiconductor of heat with a band gap of at least 1.8 electron volt, and it has a heat absorption of around 633 nanometers. Also, the foil is a metallic aluminum, and it's used as a conductive path as it transfers the electrons back and forth throughout the engine. And also, the cable lines create the negative and positive field as it is connected, and it helps move the electrons throughout the different layers. Next is the science behind our solar cell. And so, as you can see in this picture, this is the solar cell. And you may ask, how does our solar cell work? And this works by having 2 different silicon layers, as you can see, the N-type and P-type. And between them, there is a junction called the depletion zone. And the electrons from the N-type zone goes into the holes in the P-type zones. And so once all the holes are filled, the N-type gains a positive ion, and the P-type gains a negative ion. And this opposite attraction creates an electric field where it causes the movements of electrons throughout the panel, creating this temperature and thus the voltage. Next is our results. So in our experiment, we did 5 major experiments making the solar engine, and also 5 different experiments of using the filter itself. As you can see, this is the different result of our experiment. And so we experimented with the initial panel, as you saw in the first slide, and we implemented different methods to gain our final results. And so for the second part of our filter, as you can see, could you go to the next page? This is the part of our filter, and as you can see, we left this out in the water for around 3.5 hours, and after this changed this dirty water into clean water. But this is still not yet drinkable because this only filters out the lead and the copper and just some of the different fatal ingredients. Next, more on the results.
In this first experiment, we used just one layer of CD, and it produced produced 12.4 volt and 34.9 Celsius in 3 hours. However, this didn't reach 65 Celsius, the temperature that can kill the pathogens in the water. So we decided to add more layers. In these models, we implemented a new method of stacking the CD layers with a conductive pad in between, which soon activated the flow of electrons, increasing the efficiency and the speed. But still, the water temperature were not high enough. So in the last experiment, we added solar cans to the model, thus fusing the thermal solar panel. The result, as you can see, the results was great. The voltage was 24.9 volts and it reached 76.7 Celsius at its best.
So, as you can see, this is the final results. And this produced a voltage of this high and this much temperature, which is crazy. And so our experiment found a new method of a new solar cells. Using this solar cell, we gained 24.7 volt because we added a new solar can around the 4 compacted CD. This black thing is the solar can. And by adding this, the voltage increased from 19 volt to 24.7. And it reached the temperature of 75.9 degrees where the pathogens were mostly killed. And therefore, encircling this around made this much progress, and the 4 conductive path between the CD layers transfers the electrons throughout the CDs, making the efficiency and the speed of the flow of energy better in this model, thus resulting in this. And to conclusion.
So in conclusion, our experiment was a big success as the solar engine reached a degree of 76.7 and a volt of 24.9, which was obtained by implementing new eco-friendly method into the model. And the environmental problems that arose to today, such as global warming and accumulation of trash, is a big problem.
This problem into our methods. We changed these problems as good because our panel uses sun as the main source of energy, and then we use most of trash in order to make our filter. As you can see, this is mostly made out of trash. So therefore, it was made with a fairly low cost, and it filtered this nasty water into this clean water. So we hope that one day this model we made could be implemented into impoverished areas, and so that people could have clean water. Thank you.
Hello everyone, we are Sangin and Gayan and Arim. And Our title is Wingardium Leviosa, and our experiment is a magnet experiment. We talked about the magnetic levitation train and became interested in the force that the magnets of the same pole repel each other. And also, we wanted to check how the distance between the magnets will increase.
So our purpose of the experiment is to determine how the distance between the magnets will increase if we add magnetic force at the bottom of the magnets. And also we decided to make a result in a graph.
Whether graph results graph. Whether graphs are linearly or exponentially, we have to prove the graph we choose it to prove it by equations. So first, this equation, we found it from Wikipedia. This equation is using force to prove the graph. And for the second equation, we found that the spreadsheets have equation that we can make equation from the graph. So we decided to use spreadsheets using second equation. And in that equation, we put distance to find the graph.
And for our hypothesis is that distance will increase linearly, but at first we thought that it will increase exponentially, but then the size and the mass of the magnet are all same, so we thought that distance will increase linearly.
And for our experiment, we need 26 circle magnets and transparent tube to hold the magnets and mark the distance, and a ruler, pen, and Google Sheets. I think you guys might curious why we need Google Sheets as a material. We use Google Sheets to make a graph that is linearly or exponentially. And also, we can get the equation by using Google Sheets.
For our procedure, first put 3 magnets at the bottom of the tube and the top of the tube. And at this time, you should make the magnets at the top and the bottom should be same pole. And second, 5 magnets we put will go up because of the magnetic force. And third, measure the distance magnets at the bottom and the top. Fourth, every time you added the magnet at the bottom, you should measure the distance.
And fifth, put data in the spreadsheet and create a graph of the data. And sixth, check the equation of the graph and write an expected value of the distance when the magnet gets 20 at the bottom. And seventh, compare the real value of the distance. And finally, prove the result using the equation of the magnetic force.
So during the procedure, we put the 3 magnets at the bottom, and then we put another magnets under, so we can see that magnets goes off, and we can measure the distance between 2 magnets. So for conclusion, we make 3 graphs. First one is distance, second one is force graph, and third one is trend line. Trend line is used for making second equation, and this graph is the solving not risk and only the exponential lines. Let's watch video of our procedure.
So, in conclusion, we found out that the distance between the magnets increased exponentially. The distance increased about 0.2 at the beginning, but however, in the end, the distance increased about 0.1. Moreover, we expected that the value of the distance when the bottom magnet gets 8 will be 3.5, and we proved this by using the equation from the graph, this one, and that we made in our experiment. Our expectation was correct, and the real value was also 3.5. To prove our graph, we checked the graph by using first equation, this equation on the video. We put magnet's length at L, and we put distance at X, and we found this part, and force was 2000 Gauss, but we changed it to 0.2 force. So as you can see, these two graphs are same. This means that force equation and distance equations were same and the graph were same. So our experiment was successful, and we proved our result by putting graphs in the results.
So this is our citation. This is our citation. Thank you.
내가 먼저 한다고? 그럼 내가 질문도 내가 그럼 내가 질문을 했어.
쌤 들려요? 들려요? Hello guys. We are Escargo and I'm Yechan Lee. This is Do Young Koo. This is Aiden Jung.
So before starting, I'm gonna give you a question. So imagine that you are on a plane to Hawaii. However, you get into a plane crash and have three choices to select a parachute. One is a pyramid shape, second one is a conic parachute, and third one is a ram air parachute. Which one would you choose? So these are the questions. First, what shape will be the best parachute shape? And how would the velocity of the parachute change if each one had a different shape? Second, how will the hole affect the velocity of the parachute? Third, will the mass of the parachute affect the air resistance with the same shape? So, this is the hypothesis. First, the parachute with a conic shape and a pyramid will have more air resistance than the ram air shape one. Second, the parachute with a small hole will have greater velocity compared to the ones that don't have one hole. Third, a parachute with greater mass will have the same drag force with a smaller mass if the shape is the same. So this is our background research, and parachute is used for slowing down the falling object to protect from crashing. The forces that act on falling object and parachute are mainly gravitational force or gravity and drag force, or specifically air resistance. The air resistance works against the gravitational force and it can cause and is caused by the force of the falling object. I mean, it's caused by the gas molecules in the air that the object needs to break through. When the weight and drag force of the falling objects cancels each other, the object reaches terminal velocity or the constant vertical velocity. So this is the background of the drag force, and this is the equation for the drag force, and Fd is a total drag force. P is equal to the air density, while it is used as fluid density normally. V is the velocity, and Cd is the drag coefficient. A is the cross-sectional area. Cross-sectional area refers to the area on the parachute where the air resistance occurs first. So now we get on to the drag coefficient. In order to calculate the drag coefficient, you will need the following formula. The formula is a formula from drag coefficient, which is kind of changed a little bit. This equation is derived from the drag force equation. In order to find drag coefficient, we need to solve 2 times the drag force by density times velocity squared times the cross-sectional area. This is how we calculate the drag coefficient.
Okay, so what we used for making parachute was these things. Is there any razor? Yeah? No? Okay. We use thread, tape, A4 papers, ruler, disposal, and 4 coins. We use also camera for measuring the distance and time. We use electronic scale and Pixelmator Pro for checking the pixel, and also sketchandcalc.com, which is for calculating the cross-sectional area of the parachute. Also, we use air density calculator and spreadsheet or Excel. So for the procedure, firstly, we made parachutes. This is one model, okay? This is another. On my back. This one. This one, and lastly, this one. Anyway, make the parachute and measure the mass and cross-sectional area. After that, measure the air temperature and calculate the air density. So when you make it fall, you should mark the constant intervals from the shooting spot for the parachute to the end line for the data of different velocity at different height. So drop the parachute and measure the time, velocity, and acceleration. Lastly, you can calculate the drag force and drag coefficient. So as I show you, these are 5 types of model that we built. So this one are made out of A4 size paper. And the difference is that there are 6 strengths, while there are 4 strengths in here. So as you can see, this one has 6 strings, and another one has 4 strings. Anyway, what's the difference of this one and this one? It's the hole. So these 4 models had a hole of 1 centimeter and shape of a circle. However, this one didn't. Yep. So you might wonder, how can we calculate the cross-sectional area? So what we did was someone was lying down and taking a photo of the parachute while it was falling down. So this is the photo, for example, and we cut this part and we put it in the call.com, which is for calculating the area of certain shape. And lastly, we calculated it. Yes. So this is one type of data from a certain model, which one is six strings one. Anyway, we took the video and we wrote the length and time, and we calculated velocity by this equation. With velocity, we got acceleration, which is, we use this equation. Lastly, you can use Fd equals this equation and this equation to get the drag force and drag coefficient. So let me show you the database. Boom. It's not ended. Boom. It's not ended yet. Boom. Anyway, we experimented a lot and we got this result. Oh, sorry. This result. Anyway, it's time for the results.
Okay. Result, since the parachute with conic shapes cross-sectional area was dramatically changing, we couldn't calculate its drag coefficient. And the best parachute shape is a quadrangular pyramid shape since its drag coefficient is about 2. The worst parachute must be A4 shape with a hole since its average velocity was the fastest of all. And when the mass of the parachutes were changed, A404 and A414 got the different drag coefficient. And as you compare A404 and A414, we can see that the whole makes a difference in drag coefficient. And for conclusion, as we predicted, a quadrangular pyramid shape is the best shape among the 4 shapes. However, we couldn't get a conic shape's drag coefficient. And the whole of the parachute does make a difference in velocity and drag force. The difference in mass of the parachutes leads to the difference in drag coefficient. And for future directions, simple. Stability is important when we get the drag coefficient. When it is tilted, the sum of drag force become horizontally, which we couldn't count. Although we tried, we couldn't make the perfect flight, which fall down only downwards. Also, because we use paper for the canopy, its shape can be changed easily than other hard materials. As we use other materials, we can improve it. And lastly, falling objects are hard to control as we experienced the unpredictable landing spot of the parachute. With a falling object, there would be a way to calculate the drag coefficient more accurately in the controllable condition.
Thank you! Woo!
All right. 안녕하세요. There we go. All right. Amazing job to everyone who participated in the science fair. Woo! All right. Up next, we're going to have our boardwalk. So we're going to be able to go and see everyone's boards. So middle school's boards are in the library, and high school boards are going to be upstairs on the 2nd floor. All right. Your homeroom teachers have stickers for you to vote for the different boards, okay? So if you see a board that you super choaheo, then you put a sticker onto that so we can know which board is the best, okay? So remember that yellow is for high school and pink is for middle school, all right? And please don't vote for your own board, all right? No cheating, all right? We're gonna meet back in here at around